Hello, today we'll try to solve a statics problem using Excel. So the question is very simple. Find the resultant of the vectors and the angle between F1 and the resultant vector. So you have two vectors, F1 equals 8 kilonewton, F2 equals 10 kilonewton, and we need to find the resultant and the angle that the resultant makes with F1. Okay, so there are a few simple steps to do this problem. We need to find two things. One is the resultant, other is the angle between the resultant and one of the vectors. To solve the first part of the problem, there are three steps. One is move the vectors in a head-to-toe fashion. Right now, they're not in a head-to-toe fashion, so we'll move them in a head-to-toe fashion. Second is find the angle between them. Third is apply the formula, find the resultant. Okay? So here I've redrawn these vectors so that I can arrange them in a head-to-toe fashion. Right? So F1, F2. So I've moved F2 parallel to itself, right, until F1 and F2 they're in a head-to-toe fashion. So I'm calling this F2 prime. Okay? The next thing to do is find the angle between them. The angle between them is not given directly, but it's easy to find. The angle between F1 and Y is 30 degrees given here, and so the angle between F1 and x-axis, so this becomes 60 degrees. Okay, and so 60 plus 45 is 105, so gamma here is 105 degrees. Okay, so in order to find alpha, look at F2 and F2 prime. F2 and F2 prime are parallel because that's how we moved F2, and F1 is a transversal between them. Alpha and gamma, they're interior angles, so their sum should be 180 degrees. If gamma is 105, alpha should be 75. Okay, so we know the angle between them. Now we'll just come and calculate the sorry, I had already calculated these, but we'll do it again. So we'll calculate the resultant, which is given by square root of F1 square plus F2 square minus 2 times F1 times F2 times cosine of. Now in Excel we can't just put 75 here, we need to convert 75 degrees into radians, which is simple. Sorry, I'll use the reference here. 75 times pi divided by 180. Okay, so that's the result, that's the magnitude of the resultant, and it's shown here. I've recreated this triangle here, right? And so this solves the first part of the problem. We have moved the vectors in a head-to-toe fashion, found the angle between them using simple geometry, and then applied the formula square root of f1 square plus f2 square minus 2 times f1 times f2 times cosine of the angle between them. Now, in order to find the solution to the second part of the problem, which is finding the angle between f1 and the resultant, so we apply the sine rule, which simply says sine of beta divided by the side opposite to it, 10, is equal to sine of 75, right, this angle, divided by the side opposite to it, okay, which is 11.072. Okay? So now just rearranging it, we have equals 10 times sine of, again 75 needs to be converted to radians, so 75 times pi divided by 180 Okay, so 10 times 7 sine 75, right, divided by 11.072, that should give us sine beta. Now to find beta, we need to do a sine this. Now this is in radians, so we need to convert this back into degrees, which is times 180 divided by pi. Okay, so that is 60.74. That's angle beta. Okay, so we'll go over the problem again. We're asked to find the resultant of these two vectors and the angle the resultant makes with f1. So we've rearranged these two vectors in a head-to-toe fashion like this, found the angle between them, applied the formula to get the resultant. Then we applied the sine rule to get the angle between the resultant and f1. Okay, all right. Thank you for watching. Bye bye.